right, today we're talking about the circumference of a circle, and we're also talking about arc length. Okay, so first of all, tell me, what is the circumference of a circle? What measurement are we talking about when we're talking about the circumference of a circle? Something with pi, not the area. The area is the space it occupies, right? What's the circumference? Thank you. All right, so what are we talking about when we're talking about circumference? All the way around, the distance around. So when you want to find the circumference of a circle, you're looking for the distance around the circle. So we want to know how far is it to go around a circle. Okay? You have two formulas for circumference of a circle. Does anybody know them? C equals, C for circumference, pi times pi r squared is area. No. The diameter, pi times the diameter. Or, if we have the radius, what do we use? Not squared. R squared is when we're working with area. 2 pi r. Okay? So these are the two formulas you need to write down. And sometimes you can choose which one you prefer. Other times it makes more sense to use one versus the other. Okay? So write them down. Circumference is the distance around the circle. And it's equal to 2 times pi times r. Or pi times the diameter. Because 2 radii is the same as the diameter. In the very first block. Okay, oh, sorry. There you go. All right, everybody good? Okay. You guys got to get to class on time so you get your materials. Okay, so here we go. So we want to compare the circumference of this circle to its diameter. So first of all, I've actually measured this out in GeoGebra, and it says that the circumference of this circle is 18.85. And we want to know, first of all, what's the diameter of that circle? 6. Why is it 6? So 6 across, right? Through the center, from one end to the other, is 6. So how does 18.85 compare to 6? About triple, okay? A little bit more than triple, right? So if it was exactly triple, it would be 18, not 18.85, okay? In fact, do you know what fractional part or what portion, what would I really need to multiply it by? Not 3, but 3.14, okay? It's just pi. So when we're working with these things, here's an exploration that someone created in GeoGebra. I didn't do this one. But watch what happens. We can vary the radius of this circle and see what happens as we roll it out. So watch what happens as I change my theta. So we have this circle with a red circumference, and if we unroll it, the distance around it when the radius is 1 is a little bit more than 6. 6.28. If I change it so that I have a 1.5 unit radius, the diameter is 3, then 3 times 3.14 is 9 point something, right? And if I change it so that the radius is 2, then as I roll it out, I unroll it and get to 12 point something, almost 13. Okay, so all circumference is the distance around a circle. If we unroll that, the outer portion of it, how far would it go? Okay, so back to our presentation here. So pi is 3.14, 1519, or 16, and so forth, right? It keeps on going. It's an irrational number, never stops, never repeats, and you need to find it as the button on your calculator. We don't want to use 3.14, we want to use the pi button. It's going to be faster than typing 3.14, and it will be more accurate. So did everybody find your pi button? On the TIs, it's diagonal from the 7. Some of you, it's down by the decimal point somewhere. On some calculators I saw today, it was, yeah. No, I'm not going to ask you to memorize a whole bunch of digits of pi. Okay? All right, did everybody find pi on their calculator? Know how to type it in? Awesome. Okay, so we're going to use that in just a second. Here's another GeoGebra exploration. I actually made this one last night. Just comparing the perimeter of regular polygons to the circumference. And I have a little triangle down here. Everyone see my little triangle? It's itty bitty teeny tiny. Okay? It has a length of 1 for its side. And so as I make more polygons or other polygons, other regular polygons, now it's a square. Now a regular pentagon, a regular hexagon, a regular septagon, octagon, nonagon, decagon, 11gon, dodecagon. What's happening to the circle that circumscribed on? Getting more sides, and they're getting closer and closer to the circle, aren't they? Closer and closer and closer to the circumference. And watch what happens when I take the perimeter of this figure and divide it by 2 radiuses, 2 radii. 3.1, 3.11, 3.12, 3.12, 3.13, and suddenly we're getting close. Now we're at 3.14 when we're at 28 sides, and we stick with 3.14. And see how close those sides are to the actual the circle, the arc of the circle. 40-sided figure. Okay, so to keep moving, I want you to find the circumference of this circle. All right, so which of the 2 formulas are you going to use? Yep, we're on this one. The one that's labeled number 4 on your sheet. We see the center. What's the center of this circle? -1, 0. Okay. From that center, how far is the radius? 5. Okay. So are you going to use 2 pi r or pi d as your okay? Then you better find your diameter. If your radius is 5, what's your diameter? 10. Okay. So if I want to find the circumference, I want you to write this formula down every time you use it. It's good practice, and it's going to help you prepare, because this is your formula sheet for this chapter. Okay, so the more that we know these formulas, the more we write them down, the better off we're going to be. You will be able to use this formula sheet on your test, but I will do a quiz over formulas. You will have it on your test, but I'll quiz you over it without this. It'll have blanks. Yep. Okay. Your pi button. Okay, find it. So this is your formula sheet. The more you write these down, the more likely you'll memorize them so that you'll be ready for your formula quiz. Make sense to everyone? All right, so in this little box or wherever you have some space, I want you to write either pi times d, c equals pi times d, or c equals 2 pi r. If you're using the pi times d, you're going to take 10 times pi. If you're using the 2 pi r, you're going to take 2 times pi times 5. And our answer? Good question. This gets people stuck sometimes. Does the order matter? When we're multiplying left to right, does it matter if my 2 is with my 5 and then multiply by pi? No. Does it matter if my pi is first and then my 5 times 2? No. Just don't confuse yourself, okay? So order of operation here does not matter. Left to right, as we multiply, we'll get the same thing as if we multiplied right to left. Okay? All right, and so our final answer. So we're going to take 2 times pi times 5, or 10 times pi. And 10 pi is a perfect answer. There's no rounding errors. So you could leave your answer as 10 pi. But if you want to practice using that button on your calculator, you take 10 times that pi button, and we get 31.4 to 1 decimal point, or 31.1442 to 2 decimal points. Okay? Okay? So this is this first number, the one that's labeled number 4. So right here. Yep, write the formula, write what you plugged in, and then write your answer. It's about equal to, since we have this squiggly mark because we had to do some rounding, it's about equal to 31.4. All right, questions on this one? All right, let's keep moving. We want to find the circumference of a circle now when the radius is 7 inches. So which of the two formulas are you going to use? Yes, 2 pi r, because they told you radius, didn't they? Okay, so you have two formulas to pick from. But if they ask you to find the circumference and they give you a radius, then it's probably a good idea to say, hey, I need circumference formula. I have two to choose from, but I've been given a radius, so I want to use the 2 pi r. Or you can double the radius and use the diameter formula. Absolutely. Okay? Your other formula could be c equals pi times the diameter. So we're going to use this one because it's 2 times pi times 7. The last one we used, it didn't matter because you could look at it and decide what the diameter was or what the radius was. Okay? So it's your choice. And so what do we get? Okay? 14 pi is the best answer, but it's about equal to 43.98, right? So 44. Okay? Questions on this one? Okay? All right, let's keep moving then. Now we want to know what is the radius of a circle if the circumference is 6 centimeters. Okay, so we've got a little tire. We measure the distance around it at 6 centimeters. We want to know, hey, what is the radius of this guy? Okay, so write your formula down. Which one are you going to use? What are we trying to find? Radius. So which of the two formulas do we want to use? 2 pi r. We're trying to find the radius. What did they give us? 6. 6 is the circumference. So we put 6 in place for circumference. And how do we get the r by itself? Divide. We're going to divide by 2 and divide by pi. Okay? So if we divide by 2 and divide by pi, in your calculator, you would either need to divide by them separately or you need to put them in parentheses when you divide. Okay? Otherwise, it's going to take it 6 divided by 2 and then multiply that by pi. So on your calculator, this is what it looks like. So we are going to take 2 or 6 and divide it by, in parentheses, 2 pi. And my pi button on this one is, oh, it has one right here. Okay, does everyone see why we need parentheses? Yes, makes sense? You can divide 6 by 2 and get 3 and then take that divided by pi. Okay? Just don't fall in the mistake of putting it in the calculator wrong. Does that make sense? You can do 2 equals, but if you want to put it all in one, you need to put parentheses around it. Oops, and I don't need that plus. And we get 0.95. Everybody cool with that? Did everybody get that? All right, so our answer is 0.95 centimeters. All right, next one. Now we want you to find the diameter of a circle that has a given circumference. So which of the two formulas are we going to use? Nope. Pi d. This one makes more sense to use pi d because we are trying to find the diameter. Okay, so C equals pi d. The circumference was 50.26, so we plug 50.26 in there, and we divide it by pi. And what do we get? So it's 15.9 something. 16 is close enough. 99. We're going to call it 16. We always had a little bit of rounding error when we're dealing with pi. Adam, did you have a question? Got this one written down? Eric, do you have this one written down? All right, we're good? All right, here's where it changes. Okay, so we were trying to get the diameter by itself, so we had to divide by pi. Okay? D is the diameter, 16 centimeters. Okay? All right, so here's where it changes. Here's where we have to apply what we learned last chapter to what we're doing this chapter. Now, we're asking you to find the measure of, what does that symbol mean? Arc, PIE, okay? And it says pi. So if this is arc PIE, whenever we see three letters in an arc name, we know that it's either a major or a semicircle, right? Is this a major or a semicircle? Major arc, okay? So what will the measure of this arc be? 270. Why is it 270, Jaden? Good. So if that's a 90-degree central angle, we have a 90-degree arc. Whole circle's 360. 360 minus 90 gives us a 270-degree arc. Okay? So here's where it changes. Okay? Now we're going to ask you to find the arc length. Okay? We want the arc length of major arc PIE if the radius of the circle is 3 centimeters. So we want to know how much blue ink did I use? How much blue string would I have if I covered this and then I measured it out on a ruler using centimeters? 270 out of 360. We have how much of that circle? 3/4 of it, don't we? So 0.75 times the circumference, don't we? It's not a whole circumference, not the whole circle. We just have 3/4 of it, 0.75 of it, 75% of it. Does that make sense so far? And so do we have a radius or a diameter here? Radius, so we probably want to use 2 times pi times r. Absolutely. We can do 6 times pi, 6 instead. So 0.75 times 6 times pi is going to get us 4.5 pi is the most accurate answer. Good question. So once we see that we have some measure, they have to give us some arc measure. They have to tell you something about it. So in this case, we had our 90-degree mark. Okay. Then we had to say, okay, well, how many degrees are there in a whole circle? Because I have almost all of it. I have 360 minus that 90. And that's where we got our 270 from. And I purposely chose this because most of you can look at that and say, hey, that's 3/4 of a circle, right? We're used to, and a quarter of it is taken out. So we're used to dealing with 3/4, aren't we? More so than 270 out of 360. Make sense? All right, so other questions about this slide? All right, we're ready? Here we go. So arc length is nothing more than a portion of the circumference of a circle. Okay? And we find out how many degrees we have divided by the 360 in the whole circle. Okay? So here's an example. How many people have had stuffed crust pizza? Okay? I haven't. I've never tried a stuffed crust pizza. Never. Okay? I'll have to try it sometime. This one is fake. It's actually a pizza fraction box that I have that I bought for my kids to learn fractions. Okay? So we have a pizza. Okay? If we want to know just how much stuffed crust we're talking about, that's when we're talking about arc length. If we wanted to peel that stuffed crust off to see how much cheese, right, how long the original cheese would have been and how much is left, that's what we're talking about when we're talking about arc length. Not how much pizza we have, just that edge of the crust. Does that make sense? So far, so good? Okay. So if this was a 16-inch pizza, okay, a large pizza from Pizza Hut or wherever you happen to go, and we want to know how long is this blue line, then we say, guess what? We need to know how much of the pizza remains. So half of a pizza and an eighth of a pizza is how much of a pizza that's left? 5/8. 4/8 plus 1/8 is 5/8. So we have 5/8 of the pizza. That means we need 5/8 of the circumference. Eric, take your earbuds out, please. Turn your music off. Okay, thank you. So let's find out. 5/8 times. Now, when we're talking 16-inch pizza, are we talking radius or diameter? Diameter. Can you imagine a 16-inch radius pizza? It'd be almost a foot long, or a yard long, actually. Almost a yard long. Okay? Wouldn't be able to get it in the car, right? We'd have to twist it sideways, and delivery drivers would have problems. It does sound. I'd like to. All right. So 5/8 of the circumference, and we're using pi times d for our circumference formula because the diameter is 16. Okay? So 5/8 times pi times 16 is going to get us 10 pi, isn't it? And so that should be about 31.4 inches of cheesy crust if we laid it all out, peeled it off and laid it out. Make sense? Guys, we need to focus, please. Okay? Questions on this one? All right, let's switch it up. Now this time, it was about 31.4 inches. Yep, so it should be about 31.4. Okay, so here's another problem, okay? This person didn't cut the pizza normally. They cut it in half, but then they had another one that was about a third of a pizza that was left. And so we now want to know how much stuffed crust we have. Okay, again, not a full circumference, but a portion of the circumference. So if there was 60 degrees removed, how many degrees are left? 300. So now we don't have a full circumference. We have 300 out of 360. 300 out of 360 times our circumference. Are we using pi d or 2 pi r here? 2 pi r? Might as well use pi d because we've got a 12-inch diameter, right? It is. So 300 out of 360 is going to reduce to 5/6. And 12 divided by 6 is 2. So 5 times 2 is 10, right? And so again, we get 10 pi in this case because it was a smaller pizza, but we had more of it left. So once again, we get 31.4 inches. Okay? you guys get this written down? You'll have problems like this on the homework. 10 and 11. No, this is the notes. Okay, everybody good? All right, so here's where it gets tougher. So if you've been focusing and paying attention, you'll be fine. But if you've been off task and talking, you're not going to understand this. Now they're saying we want to find the circumference of circle A. And they've given us two measures. Looks like about a third of the circle, right? 120 would be about a third, right? So we got 125. We got a little bit more than a third of it that's being taken out or is left. So let's just do our 125 out of 360, right? So 125 out of 360 is the portion that we're working with here. That times the circumference is going to be equal to the arc length, isn't it? Does that make sense? Okay. So we're wanting to know, first of all, they went backwards now. They said, hey, this portion right here is 3.5 centimeters. Okay. Earlier when we were trying to find that number, we took the fractional part of the pizza times pi times the diameter to figure out what that arc length was. Okay. Now they said, hey, here's your arc length. Can you tell me how big the whole thing was to begin with? Okay. So if we're multiplying by 125 over 360, how do we get that c by itself? We're going to divide. We're going to divide by 125 over 360 or multiply by 360 over 125. So these guys cancel. Okay, so if I multiply the right side by 360 over 125, I need to take 360 over 125 times the left side to get my c. And if you'd already multiplied or divided that out in your calculator, that's okay. Just take your 3.5 divided by whatever number you just had, divided by your answer. Okay? So when we do that, yep, we get 10 centimeters. Okay? The distance all the way around was 10 centimeters. We didn't need to know the radius or the diameter because we knew what fractional part we had and how much that arc length was. Question? Just a moment. Yep. Okay. So far, so good? What questions do you have on this one? Okay. How to set it up? Okay. So let me explain again. All right. So when we want to know how long an arc length is, okay, to find the arc length, we take the fractional part, degrees over 360, times the circumference. Okay, because we don't have the full circumference, we just have a portion of it. 3/4 of it, 7/8 of it, something like that. Okay, and so we're working in degrees now. So when we know the arc length, when the 3.5 is given, they told us this piece right here is 3.5, then we can use the portion of the circle that we have to figure out what the circumference was originally. Okay? So we can take the 125 out of 360 and try to figure out what C is. Does that make more sense? Okay? So what we're probably missing is just this on our piece of paper. Somewhere on your paper, guys, write down arc length equals something over 360 times circumference. Length. How long is the arc? Okay, so somewhere on your paper, write arc length equals the degrees out of 360 times the circumference. And I think that will help you. Can you find a spot in your notes somewhere? All right, so far so good? Does that make more sense? Does that help? Okay. So I think we're just kind of missing an informal formula that really hasn't been defined. Okay. So we didn't need to know the radius. We didn't need to know the diameter. We could do that if we knew the arc length and we knew what measure we had for our arc. Okay, so now we want to know what is the measure of arc PR. So we want to know how many degrees is this minor arc. Our central angle is the same as that arc, and we want to know how many degrees is this. Okay? So what was the formula I just asked you to write down? All right, so we don't know what x is, do we? Okay, what is the arc length in this example? 9.64. So we're putting 9.64 in that spot. We're trying to figure out what x is. And how are we going to find the circumference here? 8.5 times 2 to get our diameter times pi. 17 pi, right? Okay, so that is 17 pi times x over 360 is 9.64, so 53.4 times x over 360 is our 9.64. Good question. Okay, we're going quickly, and you've got a lot of distractions behind you. Cam, put it away. We're going to have a new seating chart tomorrow. Okay, because you guys can't focus and pay attention. I don't. Okay? We have one last chapter to go, guys. And if you're not focusing, it's going to be tough. This isn't hard material, but you got to focus. Okay? All right, so here we go. We were okay with this, right? We're just losing you where we got numbers from. So this is just Josh with his mental math capabilities saying, hey, I know 8.5 times 2 is 17, because 8 times 2 is 16, and add a half times 2, we're at 17. So that's where he got the 17 pi from. Okay? And then he plugged that into his calculator. And he's going to keep that in his calculator. That's where the 17 pi went. Okay? So he's just trying to simplify, do one thing, one thing, one thing, eventually get to x all by itself. Okay? Okay? So 9.64 equals x divided by 360 times 53.4. Okay, what do you want to do next? Cross multiply. Let's get rid of this 360, right? The 360 is a pain. So if I multiply by 360 or cross multiply, no more 360 in the bottom. So this is just calculator work from here. But if you write this down, then I know you made a mistake somewhere in your calculator work, not that you didn't know how to do the problem. Yep, 3,470 sounds right. And then what do we have to do to get the x by itself finally? Not subtract, but divide. Yep, divide by 53.4. And we end up with 65 degrees. Okay? Questions on this one? Okay? So it's just a bunch of calculator math, but you have to make sure that if you're doing these things in your calculator, that you're trying to solve for one of your variables, and if you're dividing by a whole bunch of them multiplied together, you put them in parentheses. Or divide, enter, divide, enter, divide, enter. Okay? All right. So here's a little car problem. We've got a monster truck. And we know that the radius of a wheel is 4 inches. And we want to know in 8 rotations of that wheel, how far does that monster truck get to travel? Okay? So, okay, more than that. Right. But so when we're wanting to find out how far it travels in one rotation, what would we use? What formula? What's the distance around a tire? The circumference. So we need pi times d. And if the radius is 4, then the diameter is 8. So we need pi times 8. So roughly 25.1. That's one rotation times 8. So 201 roughly. And we want to know to the nearest foot, right? So we divide by 12. About 17 feet. Kind of crazy, huh? 17 feet when it has gone 8 rotations with a 4-inch tire. Make sense? It seems too far, doesn't it? Okay, so the 4 came from the fact that they found the diameter right away. Yep, I just didn't write it. Okay, so that's where that's from. And then we found that and we multiplied it by 8 to get 8 rotations, not just one circumference. And we end up with about 17 feet. Okay, all right. The 12 came from 12, so this was in inches. And there are 12 inches in 1 foot, right? So we're doing a conversion. Okay, very quick. All right, here we go. So last real quick example, and we're not going to work this one out. I just want you to see something like this so you know how to set it up. Okay? So you see this, and if you fly overhead over a field, a farm field, where there's central pivot irrigation. Okay? Or, yep, there's lots of times that you can see something like this. Okay? So if they were wanting to know what's the path around this particular system, then we know that this radius is 100, so the diameter is 200. So this piece is 200. This piece is also 200. 200 down here, and 200 over here. Okay? But then we have to get the circular parts, don't we? So how would we find this circular part? Yep. So we have 1, 2, 3, 4 of these fourth arcs, right? So 1 full circumference plus all of these 200s. You can't, because then you would end up with extra space. See how this part's not being used? You'd be traveling too far. Or you're just saying, can we make it into 4? So here's 1. Here's 2. Yep. Here's the third one. And the fourth one. Absolutely. So 4 times 90 is 360, right? 1 full circle. And the 200 times 4. Nope, well, yeah, we take the 200 times 4 and get 800, right? So plus 1 full circumference. Yep. Okay. Assignment is a book assignment. Okay. And it's on your sheet. Okay.